Okay, introduction to chemistry, unit one. Uh, in in chemistry, okay, we have something called matter. Matter is anything that has mass and it takes up space. Now there are general three states of matter. Solid, by definition, it is something that is rigid. Okay, this is something rigid, has fixed shape. Examples are like something like ice cube, diamond. And then the second state of matter is here liquid. Liquid is anything that has definite volume, but it would take the size of the shape of the container. For example, if you have a glass of liquid water, that liquid water would take the shape of the glass, whatever the size, the shape of glass that you have, water would take shape of that glass. Gas, gas has no fixed volume. It will just expand, take shape and volume of the container. Okay, something like air, helium, oxygen, nitrogen, those are state of matter, gas. Okay. Now here are some pictures, okay, some drawing that represent solid. You can see that the matter, the particles are kind of packed. It has fixed volume. It does not take the shape of the container. Unlike liquid, okay, liquid takes the shape of the container, and you can see the particle are kind of more dispersed. It's not as well packed. And the last one here, these are the gas. Gas particles are all spread apart. It will take the shape of the container that it is in. Now, when you talk about matter, okay, matter will have two types of properties. The first one is something called a physical property. Okay, so it is something that you can observe, and then it doesn't change that substance that you're looking at into a new substance. Here are some examples of physical property: color, the melting point, the boiling point, density, electroconductivity. Those are the physical property of the matter. Okay. Another type of property the matter will have is something called a chemical properties. Now, chemical property would describe how that matter or that substance can react with another substance. For example, if you're talking about sodium, element sodium, okay, it can react violently with water. So that because it can react with water and turn into something else, this considered to be a chemical property of sodium. Now, let's take a look here. Okay, here are some examples. We're going to go through all six problems. The boiling point of certain water at 78 degrees Celsius. Now, because you're talking about the boiling point, therefore, this considered to be physical property. Okay. Number two, diamond is very hard. So we're talking about the hardness of diamond. We're not talking about its chemical property. So this is a physical property. Sugar, fermented to form alcohol. You can see in this case, sugar will undergo chemical reaction and change to alcohol. After this reaction is done, sugar is not sugar anymore. It becomes another compound. So number three here, this is a chemical property. Okay. A metal wire conducts an electricity. Okay, for example, if you have copper wire and you run electricity through it, after you take the electricity out, copper is still copper. It doesn't change to a new compound. So this is a physical property. Copper metal is denser than water. When you talk about density, you're not talking about chemical reactivity. So number five, it is still physical property. gallium metal melts in your hand, and you're talking about melting point. So yeah, this is a physical property. Okay, so now when you have physical property, chemical property, we have another thing that we call the physical change and chemical change. Okay, physical change meaning that you just physically change. You're not changing the chemical um, composition of that compound. Something like ice. Ice, you know that it is solid water. Okay, and we all know that water is H2O. Now, if you heat up ice and ice melts into water, now water is still water. H2O is still H2O. It's just changing state of matter. Water molecule just kind of separate apart, but it is still staying intact. And if you heat it some more, it means that the liquid water will undergo evaporation. And then after water evaporates, it becomes steam. Now, in steam, you can condense the steam and it can come back to become water. But that means that the water molecule just kind of split apart. The water molecule does not breaks apart into other compounds. So this is physical change. You can always recover water back when you lower down the temperature. Okay, now that is a physical change. Now, in terms of chemical change here, if you have Fe, okay, iron, and then it undergo oxidation reaction to form a new compound with oxygen in the air, you can see that Fe now is not just Fe anymore, it's Fe combined with oxygen and form new compound. Okay, you can see that it incorporates oxygen atoms here. So this is going to be rust. So iron is not the same anymore. It forms a new compound. Now this considered to be a chemical change. Now let's take a look here. Let's look at a few problems. Iron metal is melted. Okay, so melted. So this means that it is a physical change. When iron combined with oxygen to form rust, we talk about this. This was an example. So it is a chemical change. When wood burns in the air, okay, so wood burns after it burns. I mean, wood has to undergo chemical reaction with oxygen in the air, and it burns and turns to another compound. So this is a chemical change. A rock is broken into small pieces, but the chemical of the rock doesn't change. It just breaks down to small pieces. So this is a chemical change. You light a candle. That means that the wick has to burn, react with oxygen in the air, and the wax has to burn also. So this is going to be chemical change. Alcohol evaporates. So you're changing from the liquid state to gas state. So this is going to be a physical change. Grass grows. When it grows, I mean, there has to be some photosynthesis going on, right? So this is chemical change. Food digest. After the food digests in your stomach, I mean, you cannot, recover the steak that you ate after 2 hours, right? Because that steak turned into something else. So this has to be chemical change. Sugar dissolved in water. When you evaporate out the water, you still can recover sugar. So this is a physical change. Apple is cut. Well, apple is still apple, right? Because it just turned to small pieces. So this is a physical change. Okay. So now, when you talk about elements, okay, elements here are the periodic table. Okay, you don't have to memorize the periodic table, but you have to know how to use it, and I'll teach you how to do that. It is a building block of compounds, and you cannot break it down any further. Okay, and if you click over here, this is the link to a printable periodic table. Now, here is the difference. Okay, element is a building block. When you put the elements together, it becomes a compound. For example, water composed of the element oxygen and then element hydrogen and hydrogen. You see, when you put together in the ratio of 2 hydrogen per 1 oxygen, it becomes a compound. Okay, now they bind together in special way to form a compound. It has to be a certain way, because if you don't have 2 hydrogen and 1 oxygen, it is not going to be water. It has to be this ratio. And you can always break compound back to element by using chemical change. Something like CH4, this is something called methane. Now you see this is a compound because it is composed of carbon and then 4 hydrogen atoms. Okay. Now in order to be methane, it has to have 4 hydrogens and 1 carbon. Okay. So now, students usually get confused between atoms, molecules, compounds. Now let's make sure that we are clear about this. Okay, molecules. Molecule is not molecules can be element, molecules can be compound, but by definition, molecule is made when 2 or more atoms are chemically bound to each other. So you can see that this is a molecule because it has 2 or more atoms, but there are 2 different types of elements. So this is a compound, and this is a molecule because it has 3 atoms attached to each other, but there are 2 elements. Okay, more 2 or more elements in here. So this is a compound. This is a molecule, but it is not a compound. It is an element because you have just one type of element. So it is an element, it's not a compound. Over here, this is a molecule and it is a compound because you have 2 different types of element in one molecule. Okay, so here you have atoms, molecules of element, molecules of compound. So these are definition and the explanation. You can see that this is atomic element. It is not molecule. And this is molecule. It is still element, but it's element in the form of molecule. Okay, so this is a mixture of 2 types of atoms. This is a mixture of the atom and the molecule of elements. Okay, so these are a mixture of 2 types of elements. And this is a mixture of elements, but both elements are in the form of molecules. This is a mixture of element and compounds. Okay. And this one here, this is just compounds. Okay, it is not a mixture. Now, since we're talking about mixture by definition is a combination of 2 or more pure substance. But in each substance in that mixture, each substance still doing its own thing. Okay, they're not chemically combined. They're just physically being with each other. For example, like if you have Fe and sulfur, okay, because they're just physically combined, they don't chemically combine. You can actually use magnet and you can just fish out the iron, okay, leaving the sulfur behind because they're not chemically combined. Okay. Here another example. This is you have a mixture of 2 types of elements, and each one of them exists in molecule. This is molecule of hydrogen, and this is the molecule of oxygen, and this is a compound. Okay, so you can see the difference here, and you can go from here to here by using chemical change. Okay, so I hope you understand the difference between mixture and compound. Okay, compound here, hydrogen and oxygen has to be chemically combined. They're not chemically combined. They just physically exist with one another. Um, Now, there are different types of mixture. There's something called a homogeneous mixture. That means that when you mix the two chemicals together, it looks like it is exists in one phase. Okay, so for example, if you have sugar and then you put sugar in the water, you mix it up, it becomes sugar solution. And then sugar solution looks like it's just a clear solution, but in actuality, there are two compounds in there. When you evaporate out the water, you will recover the sugar. So you know that they're not mixing, and there's no chemical reaction going on between sugar and water. Heterogeneous mixture. Okay, so you have two types of solution in here. So this is, let's say, it's oil and water, and you mix it up. You can see that it would generate this bubble. Eventually, it would just separate to two phase again. So this is heterogeneous mixture because they're not homogenized. You can see there's region of one chemical, and this is a region of another chemical. Okay, solution. We used a lot of solution in chemistry, and you should know that it is a homogeneous mixture. It is composed of at least two things. Okay, it has to be solute and a solvent. A solvent is the one with the larger portion, larger amount, and then solute is the one with the smaller amount. For example, like last slide, like sugar and sugar solution. Sugar is a solute, water is a solvent. Okay, and then we have this term called aqueous solution. When you refer to aqueous solution, you know that water is the solvent. Okay, here it is. You have solvent, solute, okay, sugar, water, dissolved, sugar, and then you have sugar solution. Here, let's take a look here. We have gasoline. I want you to identify whether it is pure substance, homogeneous mixture, or heterogeneous mixture. Gasoline. Okay. Gasoline is a homogeneous mixture because it's composed of different type of chemicals in the gasoline. A stream of gravel in the bottom. There's gravel in the bottom. There's water running through in the stream. So it has to be a heterogeneous mixture. Air is a homogeneous mixture because in the air we have hydrogen, nitrogen, helium, water vapor. But the solvent in the air is nitrogen because the air that we breathe in, 70% of the air is nitrogen. Copper, copper is a pure substance. Brass is a pure substance. Okay, brass is not a pure substance. Brass is a homogeneous mixture. Okay, um, I think, yeah, I'm gonna cover right here. Sorry about that. Table salt. Say about NaCl, that is a pure substance, pure orange juice. Okay, so that is a um, pure orange juice. It is a heterogeneous mixture. All right. Last thing. Okay, so sorry, I asked a question before I lecture over here. Alloy. Okay, alloy is a homogeneous mixture of elements and it has metallic property. And okay, let's take a look over here. This is a pure metal. Let's say this is copper. Okay, and then you have copper atom. Okay, this exists in individual atom. Now, if you were to take a few atoms of copper out and replace it with zinc. Now, if you look in the periodic table, you can see zinc and copper, they're next to each other. They have about the same similar atomic size because you're substituting copper by zinc. So this is called a substitutional alloy, and this is a homogeneous mixture. Okay, and then you have something called interstitial alloy. You're not replacing any atoms here, these atoms are Fe iron, okay, and then you just kind of like adding carbon atoms in between the iron atoms. So this gives you the interstitial alloy. Now you can mix the two together, interstitial and substitutional alloy, which is give you this last picture. Okay, summary. Okay, you have matter. Matter can be either pure substance. Okay, if it's pure substance, it can either be element or it can be compound. Now, if you have mixture, matter can be the mixture can be either homogeneous mixture or heterogeneous mixture. Okay. And this is the lab I want you to do when you come back on the in the second meeting. I will have sand and salt, okay, waiting for you. And then what you have to do is you have to separate sand and salt out, and then you can see that you have salt water. Okay, you can filter out the sand first. Okay, it's like you filter out the orange juice, and you filter out the sand, and you're gonna have salt water, and then you can evaporate out the water, and then that will give you the salt, leaving the salt behind. The last thing is distillation. This is a little bit more sophisticated way of separating salt from water in salt water. So if you have salt water here, you heat it up. Of course, salt has lower boiling point. It will evaporate, become steam, wa- um, and then the gaseous water will evaporate, go up to here, and then hit the bulb of the thermometer. So you can read the boiling point of water, which is going to be 100 degrees Celsius. Water vapor start to migrate down. Now, once this water vapor migrate and hit the condenser, because the condenser is basically is a another glass tubing that kind of jacket over this little tubing here, and you put cold water in. When the vapor water comes over here, hit the cold water, it will condense back into liquid. Okay, and that's it for unit 1.1. And if you click over here, it will link you to homework 1. All right.